I'm Fechner from Consulting Work, and yes, we do have a logo. I would like to use the next hour to talk to you about, ABL legacy code refactoring. Refactoring of code typically discipline when we're modernizing open edge applications. And legacy indicates that most of these applications are usually not just 1 or 2 or 3 years old, probably usually 10 times as much, 20, 30-year-old applications or even older. And when we do that, we always try to define ways with our customers how we can use the existing code as some sort of an asset during the modernization. So I do not want to look at a modernization just as a way of rewriting the same application next to the existing one. And don't use existing source code as anything that provides value. In the end, the existing source code has been tested over decades, used by users, and very often the source code is the only functional description of what the application is doing. Who has a complete written document writing what a complex ERP system does? I don't think nobody. And that's why looking at the source code is always quite valuable. I'm Fechner. I'm director of consulting work, but I'm also working. That's actually what I like the most with customers in modernization projects as an architect, supporting them to define strategies for modernization. I'm also responsible for our developer toolkits, the Smart Component Library, and the WinKit as a product manager. I do develop in ABL progress since over 30 years now. The proof in 1994, I attended a training at Progress in Germany, transitioned from Progress V6 to V7. I started a bit earlier than that. Good. We at Consulting Work, we support organizations developing in open edge and related technology, things like user interface technology, .NET, Angular web applications, etc. Are the key areas that we focus on. Working out of Cologne in Germany, but with colleagues working in the United Kingdom, in America, and Romania, and working with customers almost all over the world. We provide consulting services, support during modernization projects, and we're a vendor of the developer tools I mentioned on the previous slide. Good. I'll skip that quickly. I want to talk in this hour about, with the modernization process, how projects could be started, strategies there, and talk a bit about architecture, target architecture of applications, and then a couple of, recurring patterns when looking at legacy code. And very often these patterns, are used by developers kind of like either an excuse or just an imminent fear that we can't do anything with our existing code because we're using things like shared variables, or we're having message statements all over our business logic, and if we wouldn't be using them anymore or couldn't be using them there anymore, then we couldn't reuse a single line of code or stuff like that. And there are solutions to these problems which might help them along the way. So one thing that's always important to understand when a modernization project starts is, why are you doing that exercise? It may be fun, but there may be more serious reasons. And for many people, the obvious answer is, implementing new user interface. The OpenEdge GUI or even TTY. We just recently started a modernization project with a customer that still had still has in production a TTY application, and that's not something uncommon too. One of the obvious things that they want to offer to their users, regardless of whether it's a direct end customer developing for their own users an internal application, or whether it's an application partner who's developing an application for the market, the user interface is getting more and more important. And well, these days, more and more organizations want to develop towards a web interface, but we're also working with customers that, for I think good reasons, decide even in 2023 to start a modernization with a modern desktop UI as a target architecture. The big benefit of web interfaces is deployment. I mean, there's no deployment to the end user's device, but it makes the whole application more complex, and there are certain challenges, simple things like printing or interfacing with local hardware, that are so much more complicated in a web application. And if you can manage deployment in a different way, then a desktop UI might make your life as a person maintaining the application significantly easier. There's also just very significantly less that the development organization needs to learn, less technologies involved, less moving parts. So I'm not speaking against web interfaces, but I'm just saying it's not the only option today. I always bring the comparison: if I open my laptop in the morning and I read my email, I could use Outlook Web Access, but I always use the fat client Outlook application. And Microsoft is a big organization with many developers. So if I tend to be using their desktop application, there must be reasons. And it's probably not just that it's my old habit for, I don't know, 20, 25 years of using Outlook as an email client. It just offers a little bit more usability to me. But anyway, it's important decision to make in the beginning. Then other applications just add mobile features or start with mobile features. Function requirements, so there may be things that you just cannot implement that easy anymore with the existing application. Maybe integration scenarios, web services, REST services, or localization, translation. When the developers say, "Ooh, it's very difficult to do anything with the code base. We cannot implement new features because it has grown so big, and we have a lot of redundancy, and redundancy kills agility," then function requirements may also become a driver for modernization. And another driver can be just the code quality or the maintainability of the code. If you get the impression that your code is not maintainable anymore, what does that mean? If developers are just afraid when they touch a single line of code that suddenly things break or things get out of sync because there are redundant implementations all over again, and that becomes a burden to changing the code, and then you have a maintainability problem. That is something where it usually gets very hard to involve new developers into the development and maintenance of an application. I mean, as a matter of fact, those developers that started 35 years ago writing that application, in the foreseeable future, they will all retire. And so either you say, "Hey, my developers retire, I need to shut down the application," or you find a way how that application can be maintained by younger developers. And this version 5, version 6 style TTY application that we just started to modernize, I wouldn't even want to start talking to one of our 26, 27-year-old developers. "Hey, Dennis, that application, that's yours for the next 20 years. I know he would run away screaming. He wouldn't want to do that. The code needs to be attractive, the application needs to be attractive to young developers, like any other aspect of the work environment. I mean, it's not just that if you give them modern code, they stay there and work free of salary. I mean, but it's also an aspect of keeping them. I mean, we had customers that said one of the aspects why we're starting modernization is human resources. We don't find developers. We hired new developers, we trained new developers, and after a couple of weeks, they ran away. And that's a problem. You invest time and money into young developers, and they don't want to stay with you. So in all these modernization drivers, they need to be agreed between all stakeholders, need to be balanced a little bit, because sooner or later, many projects come under time pressure, and then usually those goals, which are not directly visible to the end users, may be sacrificed. So then code optimization, test-driven design, that are usually the first victims of time pressure. And if that has been identified as an important goal, you really need to get the buy-in from the business, that they say, hey, yes, we want an application in foreseeable future that is better maintainable, that's test-driven. Test-driven gives a lot of safety when you make changes to the application, because you change something and immediately tens of thousands of unit tests run that give you the confidence that you didn't break anything accidentally by making a functional change. But no user sees that. They always say, oh, well, we implement the unit test next year. Next year will never come. The other thing is, when you think about how to modernize, you need to know what you consider as a constant. And here now in technology, I say I expect that in 10 years, we'll still have the ABL and PaaS in a similar form as now. I mean, Rob Strait yesterday brought a vision for OpenEdge for the year 2030, so that's a 7-year vision. So that, for me, gives the confidence that I can count on PaaS and the ABL. I would never say to you that I know what is the hippest UI technology in 2 or 3 years. Nobody knows that. I mean, we are using Angular for a lot of our front-end work. Do I know if Angular is still there in 2 or 3 years? No, you can't. So that's why, for me, the backend is really important. We need to move as much as functionality on the backend that gives us front-end flexibility, and that's the only thing where I believe you can kind of like put a bet on future-proofness. So then where do we start? What do we want to do? So assuming you have an ABL GUI application, well, you could move immediately to GUI for .NET as a modern desktop, or to web or mobile. You'd have to make a choice or a bet on the final UI technology. So let's assume your modernization project takes 3 years. In the beginning, you'd have to make a bet on what is the best UI technology in 3 years when you deliver it as a completely modernized application. And that's just a very hard thing. So what we do with a couple of our customers, we say, okay, well, we have the fat client GUI application. And we know we need to move the business logic out of the GUI onto PaaS. And we first do it with GUI for .NET as a desktop UI. The benefit of that is integration with the legacy GUI is much, much easier. Then we produce a backend where we know after 2 years, we can start putting a web frontend on top of it. And then we have a much shorter span where we need to place a bet on a new UI technology. Or we first add a few new features around the existing application, maybe a mobile application, start with new technologies, so that the development team can also gather a lot of first experience with all those new technologies. Pretty much repeating that, you have that as an example. So we could go from the Progress GUI application straight into the web, deploy that as a big bang, or we go from here, we introduce the app server with a modern desktop integrated with the GUI, so we have that side by side, and then as a later step, we start putting a web UI on top of it. It is a strategy, and some of our customers decide for that. We have customers that decide, oh, for now, we think a modern desktop GUI is good enough. And others want to go straight into the web. I mean, that's sometimes a product strategy decision, sometimes just a oh, I heard that everybody needs to go to the web kind of decision, and that's why we go there too. But it's definitely something that needs to be discussed and considered. Well, the other thing is, well, the quality of the application. If you have an application that you don't trust anymore because you know it has lots of bugs, then probably the motivation for looking at the existing application is much, much lower. But if you know, well, functionally the application does what it needs to be doing, we just need to add the new UI, then the existing source code becomes much, much more valuable, much more important. So then the question is, well, are there changes? Do we need major functional changes? One thing that usually breaks the ability to do anything with existing code are database changes. So if you know you have lots of problems in your database schema, lots of normalization problems in your database schema, and when you start the modernization, you want to fix those because you think that's a big important thing, well then doing anything with existing code just gets harder. The database schema usually breaks the ability to use existing code. Another thing that we need to look into are the skills of the development team. When an organization that just has been developing in OpenEdge, ABL, starts a modernization, it's typically not uncommon that suddenly so many new topics are on the plate. I mean, very often organizations start then with agile methods of developing. There are lots of new tools, the new architecture. We have many, many customers that before they started modernization, they didn't have any proper SCM strategy and well, not to think of test-driven and stuff like that. And so when we start the modernization there, well, there's more to learn than how to use PaaS OE. It's much, much more to learn there. Well, and if you add web front ends to it, well, then that adds a whole pile of new technologies that somebody in the team needs to understand to the desk. Good. Well, let's talk a little bit about application architecture. And the one thing which we consider being eternal valid is adhering to some of the principles of the OpenEdge reference architecture. The OpenEdge reference architecture had been introduced over 20 years ago to give some guidance for implementing app server applications and less monolithic applications. It's a blueprint, it's a high-level diagram with some documents and some of the key aspects there are, well, we separate presentation and service layers with business components separated from data access, which sometimes also gives some challenges. Common infrastructure, that's typically where framework components come into the play. If you look into that in a bit more detail, then we could add a few more extra layers in there. And how granular you get there is something where also every team of developers needs to find their own answer to. We could get much, much more granular. But then the requirement might be that a person with an architecture mindset would be designing almost every functionality. Then you wouldn't just start coding. That's what we did in the version 5, version 6 days. We just started coding. And now we want to have multiple layers, and then we need to decide, well, which piece of functionality goes where. So OERA was just a recommendation. And there were many, many options, I mean, including like whether you implemented procedural or OABL, whether you use pro data sets or not, whether you implement some or all the layers or even more, whether you choose to keep existing code or not. One thing that we think is very important because it provides a lot of value is the service interface layer, and I'll be talking about that in a bit more. That's for me one of the most important aspects of the reference architecture. Our colleague Peter Judge and myself, we were having a couple of discussions recently. We said, well, we need to somehow get to a categorization of various approaches to implementing the OpenEdge reference architecture, because also in our projects, because of different requirements and different priorities of customers with different implementations. And there are other maturity models in the industry. There's a REST maturity model from Martin Fowler. We said, okay, well, let's try to define an OERA maturity model. We haven't managed to put that blog article on our website before the conference, but it should be there pretty soon. Basically, what we define is starting from just getting business logic in the form of services deployed to the app server, different levels, different standards of how then the business logic is structured on the back end. So just moving stuff on the app server and making it accessible there to all the needed clients. Then introducing a bit more standardization, stuff that like all the components that provide data to the UI, business entities in the terminology of the OpenEdge reference architecture, use the standard interface. That means standard parameters for requests, standard return types. We have that as a first step, and the second step would then be the separation of business logic from the data access, or separation of data access from the business logic. Then in the layer 3 or level 3, extracting validation code from the actual business entities so that it becomes more reusable. It's not just validation code, but similar code. When we do that, then it becomes much easier to write multiple business entities for similar set of data, sharing certain business logic. And then the latest level we've defined so far is, instead of using tables or pro data sets for representation of data, we start using objects. And that is a higher abstraction level from the OpenEdge database, where the data is stored at rest, but it provides, again, more structure. We could define interfaces for common fields and pass then data from different sources to a common processing routine or stuff like that. And that's just not possible in the ABL with tables. You need to use objects there. It's in higher abstraction level, provides a lot of value, but has a lot more effort. And depending on where you aim to be on our maturity model there, that has consequences for your code. Pros and cons. When you write more and more following object-oriented principles, you'll have much more smaller programs. That for the developer who feels familiar with such environments, he knows exactly where what is implemented, and he knows that this is implemented just once in the system, and he finds that immediately. A procedural ABL developer who's used to spaghetti code probably feels much more familiar in spaghetti code, and that's his preference. Going to these levels, then OOABL typically becomes mandatory. I would go stronger than recommended. I would say mandatory. Then you follow certain patterns, because if you split up a long program into multiple smaller chunks without a pattern, then you're not winning anything in, I know exactly where that piece of functionality is implemented, because then you just have to look into 30 pieces of source code where it is instead of one long one. So you need to really look at what do I want to achieve and what are my, which technique do I use to get that. On the inside, when you split the monolithic data entry screen into much smaller chunks, the reuse of existing code usually gets more difficult. The structure of the existing program becomes not so easy translatable into a new structure. Then we would be looking at validation code in a procedural form. This is what's doing, this is what's doing, and then we would start implementing it side by side as new code. So again, maybe a conflict of interest between a fast modernization process and a much better code quality in the end. So I mentioned the service interfaces. So what is the service interface? The service interface is, if we look at PaaS-OE as a system, it's the entry point to it. Every call needs to go through a service interface. And the service interface has various roles. And one is the role of the bouncer, who controls whether he lets you into the party or not. And the Babelfish, the universal translator, that takes a request, maybe in JSON, maybe in XML, maybe in whatever, and translates it to what your application speaks. That might be objects, that might be pro data sets, so that in the business logic, we'd never have to deal with JSON or XML-based data. Because if I, in my business entity, in my business logic, deal with JSON, then I know that if in 5 years from now, JSON is no longer the state-of-the-art data format for services, I don't know, then I would have a problem, because then I'd have to change my business logic to deal with another type of data. That's why I'd rather go with objects and temp tables. That's much more the natural structure for data in ABL applications. So that's what we deal with in the service interface. So it takes calls from clients or other external consumers, and validates the request, including authentication, authorization, ensures the session context, allocates the service that is the piece of business logic that then actually does what the user wants to be done, and it's responsible for converting request data from whatever came in externally to internally. So that when we have to deal with a new type of consumer that speaks a different language, we just have to implement new service interfaces and not new business logic. So business logic being the most valuable piece of the application, not the front end. The front end is what everybody sees, what everybody loves, but actually in the back end, that's where all the value is. So when we now look at how do we deal with open edge code when we want to take, what I'm showing here soon is like a trigger in a order entry screen that ships an order. I think this trigger is, I don't know, 30, 40 lines of code here, so rather small. So how can we move on? How can we start with existing code and then improve it in steps that improves the quality of the code and the maintainability of the code, but without a big risk. So we start by moving it from the UI into what we call an application service. So an application service is in various architectural patterns like domain-driven design or onion architectures. We have like a round architecture diagram and not just horizontal and vertical layers. That's the layer of the application that's closest to a specific front end, to a specific application. And under the application service, we would then have domain services like business tasks or business entities that contain the business logic that has to do with the domain models, also without tables. So that's where the processes are defined, and the other stuff is then the business rules. So when we first go from a UI trigger into an application service, and that will simplify the automation during code refactoring, because we just have to look at the interface. Which parameters do we need to pass to that? And then in further steps, we will improve the code, make it reusable, try to implement single concern, and by moving it into domain services. Code deduplication typically requires design and decisions. Many applications have the same rules implemented multiple times in different UIs. And if you look closer, they're just similar, not exactly the same. So then somebody needs to decide what is right. That's not something you can automate. Maybe soon with ChatGPT or so, but I don't think that's possible today. So we start with everything in the big UI trigger code block. Then we change that. Under service interface, we have an application service. Then maybe in a later step, we take code out of the application service into business tasks, because that's where we start being reusable. Business tasks being domain objects. And then in the next iteration, we might be adding business entities under the business task. If you are modernizing over time, you will have some of these business entities already, and it will become faster and faster. It's typically that in the beginning, when you start with this approach, when you get to this level, you realize, oh, I have this screen, the order entry screen, and suddenly, immediately, I need 20 business entities or more to get here. But after the order entry screen, if you then go to, I don't know, the shipping note screen, you also need 20 business entities, but 15 of those are probably already implemented with the order entry screen. So it gets faster and faster if you aim for use there. And then you might, I mean, that's a decision you need to do. You might be looking at introducing a concept of application domains, domain-driven design. And that basically means you decide that modules become independent, that a business entity that needs data from here isn't allowed to make that call directly. It should always be going through an interface layer here. And that decouples the two modules. And decoupling, again, simplifies if you need to make changes to one of the business entities, because you know you don't have like 20 callers from all over the application that go into this business entity. And when you make a change here, all those 20 callers could be broken. You in the end know they all go through a certain interface, and you just need to make sure that you are keeping compatible to that interface, and then the risk of breaking stuff when you make changes to a component in a domain, breaking stuff outside of the domain is much, much reduced. So let's look at a little bit code. It is not the most complex application here, but it should fit on the projector. So I do have a menu item in a hypothetical order entry screen that ships an order. And if you look at the sports database, well, what might we want to do? We want to make sure that we only ship an order when it's in the correct status. When the order is promised too far in the future, then we ask the user if he's really sure that he wants to ship it already today. Maybe the customer isn't expecting it. And if you order something from Amazon, you're probably happy if you get it too soon. But if you're a business and your warehouse might be full of incoming goods and you're not expecting it, then that might be a problem. So it depends. Then we start processing the stuff. We go through all the order lines. We check whether we have enough items on hand. So if the on hand is less than the order quantity plus what is allocated for other orders, then we have a problem, then it's out of stock. We might still be able to ship it or mark it as shipped, because maybe the person doing this knows that later in the afternoon we get enough that this order could still go out. Usually there are more complex rules around that. If not, we stop. Well, and then we start marking the order as shipped, and we create an inventory trends record. And when there was no issues with the order lines, then we set the order to shipped, and all that in a single database transaction. Good. So if in the first iteration we want to move that into an application service, then at this stage we need to solve two things. We need to make it callable on the app server. That includes not relying on the record which is there in the UI, because the record that's there in the UI isn't on the app server. And we need to look at what do we have in user interaction, user interface code in that trigger block. So I had here a couple of message statements with asking the user some questions. Good, so For the order record, we pass in the order number as the primary unique key, and we need to look at the record. We need to read it. Then we start the transaction, and well, when the status is not in the right, when it's not the right status, then we throw an exception. And the infrastructure, that's then again the framework bit that sits between the client and the backend, needs to make sure that the error message, the exception, is carried over to the client. So, but there was a question. A question is something that gives the user an option. And in the OpenEdge app server, it is just not possible to execute code and at this point have a question for the user and carry on once the user's answered that. That's just not possible. It could be implemented by sending a whatever message to the front end, it's a Socket.io and web application or whatever, but that is something I would not consider best practice. So what we do instead is we move on until we are there, we realize we have a question, and then we go back to the UI. And the UI prompts the user, or prompts the question to the user, and then we retry the same stuff. So we get again to the point with a question, but now in this API there, this message service ask question, whatever it does, that knows, okay, this question has been asked before, and we do have an answer. So if we do have an answer, we know what the user decided, and we can move on. And when we move on, then in this case, we would be going into the order line loop, processing all the orders. So there we have a loop now for all the order lines. And within that loop, we again have a point where we have a question. And here it's the same. If we need to ask the question, then we return from here back to the UI. And the API remembers the answer to the first question, asks the user the second question in this loop, and if we are iterating this loop multiple times, then we would have these answers at hand. The assumption, and this makes most sense when we're not assuming that during this process we will asking the user 40 questions. I mean, that would be annoying to the user, and then we should be doing something different from the user experience. But if we have like this happening every now and then, this is a very efficient way of dealing with messages. The way how we manage the questions is each question has two identifiers. One is identifying the location in the code. That's this here. Order entry application service.ship order.item out of stock. So this string should only appear once in the application. When we started using this, we used GUIDs instead of a meaningful identifier. Since it only needs to be unique over all your source code, you could also just name the class name and the method name and something else, something that's unique. And the other is the unique identifier of the record, because when we're iterating, we're going multiple times over the same location in the code, but with different records typically. And so that becomes like a standard replacement for our message statement. And it's so standardized that we could even be replacing that in an automated fashion. Then we move on and on and on. And probably we would say, well, the code does the same as it always did. The code flow is the same, so we didn't break anything. So the risk of this transition is pretty low. But we have a service interface. We deal with this as a service. And that already gives us something. It gives us the ability to write a unit test against this. The UI trigger before was not testable. This is testable. So when I now start making further changes to this, I have a unit test that gives me kind of like a warranty that I don't break the logic. So then you might think, well, in this approach, we're starting a transaction because we're going through 20 records, and the first 10 have been already updated in the database, and the 11th one, I realize I need to ask a question and go back to the user, so I have to undo the transaction. Your DBA might say, oh, that's a bad idea. You're always reverting records. Again, it depends on how often that happens. I mean, database that has an undo, it's a feature for me, it's not a big problem. So and what we then can do is we introduce a pre-check. So we do the same process, and we move all those checks that tell us whether we have a problem or not into a method for the purpose of a pre-check. And it's like a validation for this processing routine, if you want so. And in there, we then have the questions. We check for the various conditions that might either cancel or ask questions, and then do that without modifying the records. Whether we do that in a transaction to keep a lock on the order record or not may depend on the actual use case. So that was then the next iteration, to do the pre-check, so that we know we're not, we still may have to undo every now and then a transaction, but certainly less frequently than if we always assume that for every question we have to do an undo. So and then the next iteration of improving that code would be to use the pre-check during the update, extract the code into methods, update ship order lines in this case, that do the various bits and pieces, so I break the long methods into multiple smaller ones, which isn't always as easy as it is here. And in the first iteration, these methods are still in the same class, but this method here would actually be what I would be moving into the order line business task. So taking that out of this application service into a domain object that knows how to deal with the order lines during this process. And then we have the same for the actual update to the order that may or may not be in a business task or a business entity then in the next iteration. And so we start with the long routine. First, make it runnable on the app server. Form of these messages are important there. There might be other things that we might have to do. We might have to return statuses for UI widgets, like whether fields should be enabled or disabled, or whether fields should have a new color. That are things that we solve in a similar fashion as with the message interaction service. The pre-check is something that makes a lot of sense, and then breaking it up into smaller chunks. And I call this a top-down code generalization, because we start from the top, the application service, and then out of that we extract code that then goes into domain objects. The alternative would be we design these domain objects first, we implement them, and then we write the application service on top of that, but that usually leads to a situation where you wouldn't be using the existing source code as a starting point. Business types and entities become important. Factories or service managers to provide a layer of abstraction, and define rules for who is allowed to call whom. Within the domain, everybody might call each other. Outside the domain, you might want to be going through a service interface. And then other objects that could help with code qualities is using parameter objects and make some decisions on whether all the parameters that go into such a function, what of that do we consider screen context, what of that do we consider the actual parameter for this method. That can improve the ability to reuse parameter objects and code dealing with those if you keep those separated. So global shared variables, that's not such a big problem. First, if you have a chance to get rid of them, the better. I've seen many applications that used shared applications that should have been global shared So something like the user should always be a global shared, because that's just one user to the system. But there are many applications that use a shared variable instead. Yeah, the challenge is that if we move to class-based code, we cannot use global shared variables. But we might need them for database triggers also. So if we look at a pass-away web handler, for instance, because we might want to expose our business logic to a web application, a pass-away web handler is always a class. That's the only way of implementing it. Business entities typically are classes. Database triggers are procedures. The activate procedure of an app server is a procedure. So within the activate procedure, I have a procedure that's always executed at the beginning of a call, and I know the user there. So I can use the activate procedure or anything called from there to assign something to a global shared variable. So that's pretty easy. With a shared variable, that's unfortunately not possible, because shared variables are only valid in the stack trace to the procedure that needs it. So a shared variable accessible in activate.p is not accessible in the database trigger, because that's not a direct call. So in that case, we have to, from the web handler, which we consider part of the service interface, call into an ugly intermediate.p just for the purpose of being able to access a shared variable that a database trigger might need. Well, we're not happy with that solution, but it works well. It's something that we have to do just once in an application, and then we forget about it. Yeah, dealing with messages, I've shown the solution in the ship order sample. It's just a solution for input blocking from the backend. I mean, or the fact that we cannot do input blocking for the backend. It would be possible to use socket.io or other messaging things from the backend to the front end. But also there, we can't use a wait for in the middle of the code and wait here. That's just not possible. One solution is that when the UI can foresee some of those questions, the UI should be asking them more like in a wizard kind of way. If that happens, if I encounter items that are out of stock but are delivered later this day, process the order without asking. Then that's the solution, or we use our message API. Something like that, you go from the front end to the back end, you delete the customer, and whether it has an open order or not, then the deletion of the customer may require a question whether you want to do it or not. They could say, well, replace that with, on the delete button, an option to delete customers that have open orders. Then in the business logic, we might know the answer to that question already, and we don't have to go back and forth. So that's another option to dealing with that. But yeah, a more generic approach would be the approach that I explained earlier with carrying messages back and forth and dealing with answered and unanswered questions and reusing the answers to the previously given questions until you're completely through. So that's an example of legacy code from a customer of ours. They had that in validation. There was a question which they referred to as warnings, but that were questions. And using that API, we modernized the code. It's now a slightly different call into that API, but the code before and after stays the same. And when that's being sent to the browser, it's in a JSON object with the message text, the buttons that should be shown, yes, no, cancel, whatever. And it goes to the front end as an unanswered question, because if you go through a couple of iterations with these questions, then there might be multiple questions, and also the front end needs to know which questions are already answered, because those should not be asked to the user again. So here we're having the message ID as a GUID that describes the location in the code. The message context is the GUID of the record to whom this message belongs. So that is something which can actually be automated, replacing message statements with that API, and therefore we're using Proparse. I'll briefly introduce Proparse. Proparse is something that we use as a tool a lot. Proparse is an open source tool. It is or used to be the foundation for ProLint, a rather old linting tool for progress code. And then it provides an abstract syntax tree for progress code. An abstract syntax tree just lets programs read code much easier. We don't have to deal with the formatting of the code. We don't have to deal with abbreviated keywords. We don't have to detect what is a table name, what is a temp table name, what's a variable name. All this interpreting of progress code in a similar way than the compiler has to do is done by Proparse. That's quite valuable for us. I'll show you some samples soon. The different implementation of Proparse, there's the initial implementation on the OE Hive's GitHub page. We maintain Proparse ourselves. Proparse needs permanent maintenance. Whenever Progress adds a new keyword to the language, Proparse needs to be enhanced to understand that keyword. And even though Proparse is, I don't know how old it is, probably over 30 years old, also with very old code, every now and then we find code constructs that compile, are not really documented that it works, and we have to teach to Proparse that this is valid ABL syntax and what that actually means. So it is really something that needs some tender love and care. Actually, that slide, it supports the 12.7 syntax, not just 11.7. If you want to read about this, well, there's a Java documentation for all that. On our GitHub page, there's some samples for using Proparse. This is how you start parsing code. Proparse is implemented in Java, and it can be used from the ABL through a Java virtual machine that's embedded into .NET. And since ABL can use .NET, it's straightforward to use Proparse. I mean, there are a lot of moving parts, but it works. So you create a Java file reference, and then you pass it to the constructor of the parse unit, and then you tell the parser to parse that program, and then Proparse can tell you a lot about the source code. We can visualize then the abstract syntax tree in a program, and that helps us to see at the source code in the same way as the parser does. And I have a simplified version of that. Since it's a tree, it's typically recursive. So here's the code that I had on the slide to start the parsing of that order entry program there. When we use it, we have a wrapper around some of the Proparse functionality, this Proparse helper. It does some error checking and other stuff. And then since it's recursive, we start from the root node of the program, and we pass that then into an iterate nodes procedure, which recursively calls itself. And that would now return the structure of a program in this form. It knows where the statement is, what type of statement it is. The third column or the fourth column there, it's the token name. The token name is typically like the keyword for keywords, but without the hyphen, because that is a Java keyword. That's what we would be looking for in the code. So we would be looking for variables defined as a widget handle. The nice thing about Proparse, it would be telling me widget handle also for a handle variable, because Proparse knows that it's actually the same. So again, one of these aspects where all the understanding of ABL source code is done there. Then here's a block that tells me it's a name of a record. And then I could ask this node, is it a database record, in which database, or is it a temp table, and whatsoever. And yeah, we use that to read source code. And I'll show you one use case very soon. When we're dealing with very, very old code, we might have TTY interface with update editing statements. And in update editing statements, there's actually a lot of valid business logic. So that tells me for which field it is, the validation. That is the validation rule. If find sales rep where equals customer sales rep, and then an error message. And that's the code that I want to distinguish from just the template code or structural code around it. I would never ask an OGO pending anymore on the app server. That's just not needed. So I need a way to filter the important stuff from the unimportant stuff, and that's something we can do with Proparse. And when we look then at a validation routine that could be used in a business entity, that's derived from that. We have the same blocks that had been yellow now in other structural code. This dataset helper add error string that adds an error string to a record in a pro dataset. That's something that we didn't do in the update editing statement. But the business rules in yellow here are the same. They're also rewritten. Instead of referring to data on the screen using the input keyword, they're now looking to the data that's on whatever interface on the screen as something in temp table fields, because temp tables are now typically how we carry along data between the app server and the front end. And that is something where we can write routines that do this code changes automatically. And that saves some time. And that's then time that we can use then later for optimization of the code. So, and when we look at the code that does that, we've written a lot of helping code. That queries data, we iterate stuff, and for instance, when we go through if statements, so here we're iterating through the update editing block, we're looking for the if statements, and then we look whether it has a child node with or go pending or not equal frame field, and then we know whether it's a candidate for doing that. Other people might be preferring to do these things using reg access, but I think with Proparse, it's actually a very, very powerful way. Maybe in 2 years, or maybe in a year from now, I'll be saying ChatGPT is the source for that, but today it's Proparse. Maybe Proparse needs to provide the data to ChatGPT or whatsoever, but that's how we're doing that now. And then we use this also for the UI design. If the functionality is the same, then very often the layout of screens could be also a starting point for new layouts, or not. That's, in some application it works, and other doesn't. And if we have a screen like that, then we could use Proparse to read the screen layout. I mean, an ABL-based screen layout is sometimes weird and sometimes surprising. Just this week, on Monday, I ran into a situation where a customer was having two fields here, some being colon aligned, others being left aligned. And that's something which we didn't care for yet in our tooling for determining an X and Y coordinate on the field on the screen. So we need to do that, but we know a lot of these dirty ABL-ish things already. And what we also can do, we look at this field with a button here and another field. We can look at the combination of fields and say whether that would make a good lookup. In most modern UI frameworks, a lookup is a standardized component. And if there's a leaf trigger on this field and a choose trigger on that field that have a find to the same table and not a lot more, and this field is read-only, then we can pretty reliably say that should be a lookup component as a reusable component and not as 3 individual widgets that just randomly fulfill the same task on the UI. That's something where we also use Proparse to help us there. And then we can, have to move on a little bit faster, also look at triggers like that. They also contain certain rules, but they are also tied to Progress GUI, and interpret them and pretty easy generate other code out of this. That is for ABL GUI as the target UI. We use classes, progress class that we've written for that purpose, that mimic properties and methods of progress field level widgets, but translate the behavior into .NET controls. And we have the same APIs, the same widget facades for Angular applications too, so that actually the same code could also be generated for Angular, that when you have these leaf triggers that enable, disable fields or change colors, or etc., they can also be quite easily be translated. And we can also detect code that then starts running to business entity and generate a call into the app server automatically. Good. I actually have to move to the next room because I have a presentation in 12 minutes. So thanks for your time. And well, if there are questions, you'll find me later at our booth.